Okay, so now let's work on the text data. So for working on text data, because text is going to be very huge in comparison to your gene or variation. So in this case, we have to deal with it in a different way. So we have created few functions for it. So like first function we have created to just get the count of each word, like how many times each word have occurred in this particular scenario. That is what we're going to take as the first step. Second function we have got for getting the response encoding. Now for text data, how we will perform this basically this response encoding, that's a question, because it's going to be huge for us. So let's talk about it. So again, we do have values from 1 2 3 and so on till 9. So this is my value. Now if I have to get the probability that the value is 1 given your text, this is how we work in the naive base, right? Now in this case, if I look at the basically the output for it, it is the value is going to be proportional to my value from 1 to k, and we will say probability of y is equal to 1 given basically your wi, right? So that's what we gonna have here. Now so this is what we want to compute in this case. Right now, this value can sometime can be very low also. This can be very small. So in order to handle that, we can take the log. So after we take the log, this product will get converted to the sum format. So this is going to look something like this. I'm going to take the log on both the side. So log of probability that y belongs to 1 given the text data, right? So, and because here we go with a naive assumption that everything is independent, so that's the reason we do that product. So this is going to be not equal to but directly proportional to, again this is gonna become like sum of this, because now when we take a log, this is gonna be sum, then log of probability is equal to 1 uh, given this word, right? So basically given words whatever we do have. So that's how we can do it. And then once we calculate this up, again we can take an exponent to get back the value in the appropriate format. So all these things we can anytime do. So again it looks very similar, there's nothing strange, but just want to show you that this function is doing. You can see that here also we are computing the log, right? So that's for the same reason what we are doing it, and after that you can see that we are doing the exponent also. Once we got the log output, we need to again do an exponent to bring it to delog it. So that's what we're going to do in this case. So now these are the functions which we have created. Again, these functions, I'm pretty sure you might have already kind of created or used a lot during your machine learning course. There's nothing too kind of fancy about them. Then after that, we are going to build the one hot encoder, and when we are going to use consider text, maybe we may only want to consider the words in my one hot encoder which are occurring at least 3 times or more than 3 times. So that's the reason in this count vectorizer we are considering the value of mindiff as 3, so that this is something we can take care of. Otherwise there will be too many columns going to come up. So the whole code is remaining whole code is basically to get that one hot encoder. Quite simple, you can walk through it. And once we get that, we are basically looking at the total number of unique words, which comes out to be 54,007. And when we will apply basically and definitely you can see that this is going to be huge, right? And the same way we're gonna create for response encoding, and for response encoding also we will ensure that the sum of all these probabilities should be equivalent to 1. That's something we have to ensure even in response encoding. So that's what we are doing it here. So after we have done it, maybe if you want to normalize the code, you can also do that. So that's the next step, we are doing it here. And once we have done this, this is how your values are going to look like. So you can see here that this is telling me that there are 5,732 values with which are kind of occurring, let's say 3 times. And similarly for the other, like the words which are occurring 4 times, 3,761 and so on. So this is the occurrence of word. Again, guys, I would strongly recommend you to go through each line by line, and we had made sure that we have provided all the comments to understand each and every line. You can see that for everything we have properly commented for you so that your understanding should be easier. But since they are very straightforward stuff, I'm not basically going line by line of code, because again, I'm assuming that you already know some portion of machine learning. But as I said, it's if you have any problem, just feel free to put it in the discussion forum. We will be more than glad to help you out with this. Now, once we are done with this, let's build the model. The model building stage is going to be very similar. Now, we have again taken the L2 norm, again the logistic regression. We are going to use calibrated classifier. We are going to use one hot encoding. And in the end, we're going to get this particular output. Once we get that, we can look at again the same graph to look at the minimum value for log loss for comparative alpha. Once we have done this, then we are going to compute our losses, log loss, and you can see that this log loss is coming out for test set as 1.25. In fact, it's much better in comparison to what we have got for the variation set also, right? So this is performing much better. That means this column is quite critical. And then once we are done with this, we want to look at the overlap portion. For that, we have again written a function, and the overlap is also high. So you can see that 96% here and 98% here for test and cross validation respectively, which means that my text column is highly stable and very much significant. So all these three columns are highly important. So that's what this basically tells me up. So now once we are done with this, we will do some more data preparation before we apply our machine learning algorithm, because now we need to bring all these three columns together to work and build a model. So that's what we're going to do as a next step. So we will do that basically in the next lecture.